I have analyzed all the LeetCode problems for various tags, and here are the top 10 data structures used in LeetCode problems. They give a different perspective on where to focus and where to prioritize, where to practice problems. So it is good to know, it doesn't hurt to know the top 10 data structures used in LeetCode problems. Without further ado, let's take a look. I think the number 10 is a linked list. Linked lists are dynamic data structures allowing for known for efficient insertion and deletion of elements. There are 79 LeetCode linked list problems. Some of them are very hard, like the problem number 25, like reverse nodes in K groups and other linked list problems. I think 23 is also a little hard. Merge K linked list, sorted linked list. So it is good to practice the linked list. Definitely, there is a chance that you might get in a LeetCode interview. So let's move to number 9. Number 9 is union find data structure. I need to brush up a lot on this one. I heard this data structure only while solving LeetCode problems. It is part of graphs, and it is basically a disjoint set union that tracks a set that tracks a partition of a set into disjoint subsets, and it supports find and union operations, and it is used in algorithms like Cruxel for finding minimum spanning tree. And then the another problem is like account merge. I think problem number 72 or something like that. Or I think 721. I think LeetCode problem number 721. There are 82 union find LeetCode problems. Let's move on to number 8. Number 8 is graphs. Graphs, as you know, is also complex problems. They represent relationship between entities and are essential in solving problems related to networks, paths, and connectivity. There are 148 graph problems and a lot of algorithms uh, to on graphs, so you need to be familiar with all of them. Let's move to number 7. Number 7 is stack problems. There are 162 stack problems, last in first out, and it is essential for DFS, depth first search, parenthesis matching, and then expression evaluation. So you need to know how to use stack and where to use stack in what problems. And let's move on to number 6. Number 6 is binary trees. There are 175 binary tree LeetCode problems. They're subset of the generalized tree problems, because they just have only left and right. That makes some new algorithms and new data structures kind of thing, red black trees and other stuff like that. So you need to be familiar with that. Let's move on to number 5, which is trees. These are the generic trees, not the binary trees. There are 232 tree LeetCode problems, so you need to focus on this one as well. Let's move on to number 4. Number 4 is matrices, and there are 235 matrix LeetCode problems. It represents the grid based problems, and it is used in dynamic programming. And then pathfinding, I think 1091 is to find the path from top left to bottom right in a matrix. So problems like that. And then let's move on to number 3. Number 3 is a hash table. There are like 631 hash code problems. It's a big jump. Hash code allows efficient lookups and are widely used in problems that require constant time access to elements. So it is definitely Like if you are struggling in a LeetCode problem of what data structure to use and you haven't heard of this problem, so trying out hash table, whether it will work or not, is not a bad idea. And let's move on to number two. Number two is strings. I think strings is just a set of characters. I think there are 729 string LeetCode problems, so you definitely need to look into this class of problems. There are substrings and subsequences and stuff like that. So there is some generic patterns around this which you need to focus on. And let's move on to the number one. I think you might have guessed it correctly. I think it is arrays. Arrays is the most fundamental data structure. There are 1751 array LeetCode problems, which arrays and strings, both of them, by in and out itself, they don't not like hash table or anything like that. They don't give you any pattern themselves, but you need to know, like there are like Cadane's algorithm in the case of stuff like that, which works on arrays, and you need to practice those. And comment below if you have any questions. Otherwise, I will see you in the next video. Thank you.